Welcome to lecture number 4. This one is entitled Variables in Research. In this lecture, we will cover the goals of science. And the reason we're going to cover the goals of science is because the types of research that we often conduct are tied directly to one of the 3 primary goals of science. And then we will look at the variables that the terms that we often use for specific types of research. And so in order to distinguish some of these, we need to understand the different types of research. So the reason we're going to cover these 2 in a class called statistics is because we will encounter variables like independent variable, criterion variable, explanatory variable. And sometimes this terminology is associated with the type of research that you've conducted. And sometimes it's just used interchangeably. And finally, we'll talk about problematic variables, especially the confounding variable. So, what are the goals of most disciplines? I've got the goals of psychology because this is a PSY class, but it would be applicable to nursing, sociology, you name it, most of the natural sciences and so forth, or hard sciences. And so you can divide the goals of most disciplines, including psychology, into the goals associated with the science and the goals associated with the profession. So most disciplines like psychology have a science side and profession side, and sometimes there's a gray area where it's not neatly distinct from one another. But the 3 primary goals associated with any science are going to be description, describing some phenomenon accurately, reliably, being able to predict this phenomenon, and ultimately, hopefully, explain that phenomenon. And if you do this well, then hopefully you can take that knowledge and apply it to the real world where you can control, modify, improve some aspect of that phenomenon. With the goal of description, the type of research methodology or method that we typically use is just called the descriptive research method. There's lots of subcategories here and so forth, but we typically just call it descriptive research. If you want to predict one variable from the other, sometimes we call that relational research. And I put correlational and comparative research under this box to differentiate it from the experimental methodology. But some people say it can go both places. But with correlation, if you know 2 variables are related, you can predict one from the other. And same with comparative research. Instead of looking for an association, you're looking for a difference. But if I know life expectancy of men and women have different life expectancies, then I can predict life expectancy to some degree if I know your sex, male or female. And then with explanation, if explanation is your goal, then the experiment, especially the true experiment, is the technique that we're most interested in. But I will also discuss the quasi-experiment. So we will go over descriptive research very broadly, correlational, comparative, and then 2 types of experimental research, quasi and true experiment. I will not mention the pre-experimental design, but I will cover that in my research class. Okay. So here's a little visual that just helps you out. It's just the way that I've organized it. For me, I like to classify research as either non-experimental or experimental. And when I mean non-experimental, I mean no manipulation. Here, your goal is to simply observe and measure and record behavior or some phenomenon as it naturally exists without trying to influence that phenomenon. With the experiment, you intentionally manipulate something. So no manipulation, just measurement and observation, manipulation before measurement and observation. And under the non-experimental, I put descriptive and relational. And with relational, you can have semantics, but for me, I like to think about correlational research as looking for an association, such as a relationship or association between height and weight, or grades and study time, or a different type of relationship, which is a difference. And again, it's semantics. So is there a difference in life expectancy between men and women? With the 2 types of experiment, both experiments have manipulation. The difference between a quasi-experiment and a true experiment is with a quasi-experiment, no random assignment is possible. And the reason you're not using random assignment is because you're using intact groups that already exist, but they do get some manipulation and independent variable. For example, I could have one school system gets new computers and the other school system doesn't. So there was manipulation, new computers or not, and then you could determine whether or not test scores or morale, some other dependent variable changed. But random assignment was impossible. The kids already existed in one school system or the other. True experiment, random assignment is used. And this is probably the gold standard in terms of trying to make or generate a cause and effect statement, especially if it's double-blind, placebo-controlled. This chart is showing the same thing as this little hierarchical diagram, except it just displays it in a different format. So if you're using the descriptive method, all you do is observe. If you're using the correlational method, you're observing, you're measuring, but you're also looking for an association. Is there a relationship, a correlation between height and weight, study time, and grades? With comparative, it's also a relational type study. There's no manipulation. So you still observe and measure, but your primary goal is to look for a difference. And again, these two, it's sometimes just a matter of statistical difference rather than a different type of research method. But some people like to use these just to distinguish the goals of the two, and I'm fine with that. So with comparative, you still have observation, but you're testing for a difference rather than association. And again, that's just semantics. With the quasi-experiment, they all observe, of course. Typically, you're looking for a difference, and manipulation was involved. And with the true experiment, of course, you always observe and measure. You're looking for a difference, typically. You do manipulate something, and random assignment was possible. So these two tell you the same thing in just different formats. Okay. So here are some examples of the different types. Descriptive research, we could say or ask what % of Troy students plan to attend graduate school. There's no manipulation. I just want to get a statistic out of this. I'm not trying to relate one variable to another. I'm not trying to see if men are different from women in terms of their rates of going to graduate school. It's just a simple descriptive study. Correlational, I'm looking for a relationship. In this case, we call it an association. Again, that's semantics, between study time, a numerical variable, and exam scores, a numerical variable. So correlational and comparative studies sometimes get confused. And the primary difference, at least for this class, keeping things simple, is with correlational, we'll have two quantitative variables like study time and exam scores, or height and weight, or speed and gas mileage. With a comparative study, we typically have one numerical variable and one categorical variable. So in this case, I'm looking to determine if there's a difference in life expectancy, which is quantitative, numerical, between men and women. So sex in this case is qualitative, non-numerical, categorical. And then we have quasi-experiment. So quasi-experiment does have manipulation, does have an independent variable, true independent variable, but random assignment is not possible. So in this example, I have two hypothetical classes, the same topic. One meets on Monday and Wednesday, the other meets on Tuesdays and Thursdays. And I decide to provide a study guide to one of them, to one group, and not the other, to see if scores change on a test, for example. So the reason this is an experiment is because there was manipulation, study guide, no study guide, but it's a quasi-experiment instead of a true experiment because I used intact groups. I didn't randomly assign people to be in one class or the other. They already existed. With the true experiment, random assignment is possible. All right, so in this case, I could randomly assign people in the same class to either receive a study guide or not, and see if that changes exam scores. So what are some of the terms that we use to describe the variables in specific research methods? Generically, you could use the terms explanatory and response variable, and I'll put these as generic terms. And sometimes we use the term outcome rather than response. So life expectancy is more of an outcome rather than a response, but they can be used interchangeably. And so we think this variable is explaining this variable. I think caffeine, explanatory variable, might explain heart rate or blood pressure, how you respond, or the outcome of the study. If you have an experiment, rather than using the terms explanatory or response, although you could, and a lot of authors do use the terms interchangeably, and I'm fine with that. But typically with an experiment, a true experiment, you have an independent variable and a dependent variable. And so if I randomly assign people to receive caffeine or no caffeine to examine their reaction time, caffeine is my independent variable, and the dependent variable is reaction time. Sometimes we use the term explanatory rather than independent if we're not truly sure it's an independent variable, if other variables in the study are impacting it to some degree. But the reason we call this the dependent variable is we think its value, your reaction time in this case, is to some degree dependent upon how much caffeine you gave the person. And if you're using a correlational or regressional study design, rather than use the terms explanatory or response or independent and dependent, sometimes you will see the term predictor variable and criterion variable. The problem is these get interchanged all the time. And so I will see an article where they said, here's the explanatory variable and the dependent variable rather than explanatory and response. So this is a generic classification that you will often see. It satisfies my need for organization, but sometimes you'll see these interchange, sometimes you'll see these interchange, sometimes you'll see these swapped across with explanatory rather than going to response, explanatory to dependent, and independent and response or independent outcome. That's fine. For me, for this class, I will try to keep them grouped just because of, again, that need for organization, but it's not a hard and fast rule. And so again, this is just another table to help explain these variables. So if you have descriptive research, typically you're not going to have an explanatory or independent variable or predictive variable. You're just describing some phenomenon, so you have just a response or an outcome variable. Typically with correlation, the terms predictor and criterion are used. With explanatory and response, so with comparative, often we'll have explanatory and response. Again, these are not hard and fast rules. And if you have quasi-experiment or true experiment, independent, dependent variable are typically often, probably most oftenly used, but you could certainly have an experiment where they're using the terms explanatory and response. So just because there isn't a check here doesn't mean it's not possible. I'm just trying to give you maybe a simplistic starting point. Okay. So go back to those 5 examples I gave you just a minute ago, and let's see if we can identify what the variables are. So with a descriptive study, a very simple descriptive study with one variable, in this case, we don't have an explanatory or independent or predictor variable. All we would have is response or outcome. And I would prefer the term response. Are you going to graduate school, yes or no, rather than outcome. But either would be okay. Some people would call it a dependent variable. I don't like the term dependent variable here because there wasn't a true independent variable to go with it. Again, it's a little bit of semantics, not a big deal. Have a correlational study. We can certainly use explanatory and response if you wanted to, but I prefer, and I put right here with correlational studies, to use the terms predictor and criterion variable. So in this case, I would think study time, my predictor variable, can be used to predict exam scores if these 2 variables are related. So study time would be my predictor variable, exam scores would be my criterion variable. If I had a comparative study, again, I could probably use explanatory and response and nobody would get upset, but our independent, dependent, I prefer explanatory and response simply because there's not a true manipulation by the researcher. So in this case, I would prefer explanatory and response. And I think your sex, male or female, would be the explanatory variable, and it's explaining the response or outcome variable, in this case, life expectancy. So I would prefer outcome with life expectancy, and I would prefer with whether or not you plan to go to graduate school more of a response variable, but they can be used interchangeably. So with the comparative study, I would say life expectancy is my outcome and sex is my explanatory variable. And with our two experiments, we know we're going to have an independent and dependent variable. That's the terminology I prefer. It doesn't mean it's absolute and it's always used. All right, so in this case, I have a Monday, Wednesday class, and a Tuesday, Thursday class. They received the study guide. So my independent variable is whether or not they received the study guide. And I think test scores, at least to some degree, are dependent upon whether or not they got the study guide. So study guide would be the independent variable, yes or no, and dependent variable would be scores. And in this case, same scenario, except I didn't use a quasi experiment, I used a true experiment. So again, study guide, yes or no, would be my independent variable, and how they score on a particular exam would be the dependent variable. Chose to use explanatory variable for study guide or no study guide, that's fine. If you chose to use test scores as the response or outcome variable, that's fine. You will see that as well. Problematic variables. So not all variables are desirable. We want an independent, dependent variable if we have an experiment, but sometimes there's variables that we don't want or variables that we have to be aware of. They can influence the statement that we make about the outcome of our study. So the first one, the big one for me, is a confounding variable. A confounding variable completely ruins the internal validity of your experiment. In other words, the ability to make a cause and effect statement. And that's why you are conducting an experiment. You want to explain something. But if you have a confounding variable, you've conducted an experiment, your ability to explain the outcome is diminished greatly, if not completely washed away. So a confounding variable is any unwanted variable that varies with both the independent and dependent variable. Now, on the top of your head, you might say that doesn't seem to make a whole lot of sense. All right, so let me give you an example. One of my favorite examples is a real life example, and that's the correlation or relationship between churches and bars. Is there a relationship between the number of churches in a town or city and the number of bars in a town and a city? And there is. And it may be tempting to say, well, the number of bars cause more churches to pop up. That's possible. But in this case, we certainly have a confounding variable, and that is going to be population. The bigger a town or city gets, the more churches it can support. The bigger a town or city gets, the more bars it can support, and the more police and the more animal shelters and more hospitals. So in this case, we have a confounding variable, and that's population, because population is directly related to the number of churches a town can support. And it's also going to vary with the number of bars or other institutions, or I guess in this case, businesses that can be supported. So I can't say with confidence bars cause more churches because I have a third variable, confounding variable, that might be explaining this relationship. Second kind that's problematic, it's not problematic to the degree that a confounding variable is, but you can control for it. You can be made aware of it, and it can help determine a particular relationship. And so this directly destroys the cause and effect ability if you have a confounding variable. A mediator variable doesn't do that, but it does interrupt your ability to make a direct cause and effect. So what a mediator variable is a variable that lies in between. In this case, I'm going to call it the independent dependent variable. So it explains the relationship between the IV and DV. So my example is temperature and drowning. As temperatures go up, drownings go up. But is there a direct relationship between these two? And there's not. There's an indirect relationship, because temperature increases the likelihood that you will go swimming. Swimming increases the likelihood that you will go drowning. So in other words, the relationship between temperatures increasing and drownings increasing can be explained by that variable in between the two, which is, in this case, swimming. And finally, we have a moderator variable. Again, moderator variables, mediator variables aren't as problematic as confounding variables, but they can be misused or overlooked, and they can obscure some effects. And so a moderator variable acts like a dial. It can increase or decrease the impact that the independent variable has on the dependent variable. It can even change the direction that the independent variable has on the dependent variable. And so one example I liked is the recent one with COVID and illness. We know there's a relationship between this virus and getting ill, but the severity of the illness is definitely moderated by your age. So if you become infected with this virus and you're 90 years of age, then there's a very strong chance you will be hospitalized or even die. If you're infected with this virus and you're 18 years of age, then the likelihood of you being hospitalized or dying is very slim. So you could think of age as turning up the dial or down the dial severity that COVID has. So some practice questions. The manipulated variable in an experiment is the independent variable, and that is true. And the measured variable, we would call that the dependent variable. In a study examining the effects of sleep on mood, a person's mood is the independent variable. And we're going to say that's false, because this mood is the variable that we're measuring. We think it's dependent, at least on part, on how much sleep you received. Random assignment is used with a quasi-experiment. This is false. The only time we use random assignment is with a true experiment. So the reason it's not quite a true experiment is because random assignment was not used. And because random assignment was not used, there may be some pre-existing differences between or among the groups that we have to watch out for. Manipulation is used with a quasi-experiment. That is true. It's just like experiment, except random assignment is not used. Confounding variables ruin the internal validity of an experiment. Internal validity simply means the ability to make cause and effect statement, the ability to explain the relationship between these two variables. Right? And that is true. If you have a confounding variable, you cannot make a confident cause and effect statement because there may be another variable. This confounding variable may be the reason for that relationship. So if drug improves men's health and harms women's health, would we call sex, male or female, a mediator variable? And this is false. We would not. Sex, in this case, would be a moderator variable. It's acting like a dial. So in this case, not only is it changing the impact, it's changing the direction, whereas it helps men's health and harms women's health in this hypothetical example. So it's not a mediator, it's a moderator variable. 3 goals of science are description, prediction, and application, and that's false. We know it's description, prediction, and explanation, with application or improvement, modification being more of the goal associated with the profession side of a discipline. So that's false. The terms explanatory variable and independent variable are often used interchangeably. That is true. You can interchange them. Most people won't get upset. Again, I prefer independent variable if we have a true experiment, but that's just my preference. So true. The terms response variable and predictor variable are often used interchangeably. That's false. So a predictor variable is on the left side, and it may be trying to explain the criterion variable. And so predictor variable, if you really wanted to, could be interchanged with independent variable or explanatory variable, but response is more like a dependent variable or a criterion variable or outcome. So this is false. A researcher discovered that the treatment group was much younger than the control group. As such, this makes age a confounding variable. Is this true or false? This is true. So if I have two groups, one that received, let's say, caffeine and the other didn't, and I notice the treatment group is faster in their reaction time than the control group, and I also discover that the treatment group is 10 years younger than the control group, I'll never be able to say if it was my treatment, the caffeine, or age, or some interaction. So it's ruined my internal validity. And I just can't make a cause and effect statement about caffeine and reaction time. A researcher wants to know if college graduates earn more than high school graduates. So there's no manipulation here. I'm not randomly assigning people to be college graduates or not. I just want to know if there's a relationship between, in this case, income and your education level. And since I've divided it into college graduates versus non, I would probably do a comparative study, but statistically, we could make it a correlational study if we had to get the same result. But there's no manipulation. So this is definitely not an experiment. Quasi-experiments use intact groups and manipulation. That's true. They don't use random assignment because the groups already exist, but they do have a true independent variable. And that is the end. As always, I hope this helps. Feel free to call, text, email, or set up a Zoom meeting.